Hi everyone, my name is Xiangyu, the leader of Team 10 for SER502 semester project. The team members are Katie, Rendong, Ximing, and me. Today, we are going to demonstrate our work on the design of our language and the compiler and the runtime environment for our language. This is our grammar rules. We have supported Boolean expression as well as integer type. We are using is to do the assignment, and we are using var to declare variables. We also supported if-then and if-then else statement to make decisions. And we supported for statements for iterative execution. In addition, we supported print statement to print out the value or variables in our virtual machine. This is our bytecode. We supported 5 types of bytecode in our virtual machine. Type 1, declare variables. Type 2, assign variable to variable 1. Type 3, performance or arithmetic operation between var2 and var1. And type 4, compare and jump operation. For compare, it was comparing between var1 and var2 using var1 minus var2 and setting to the flag register. Then jump based on the flag register's result. And type 5, we will output the values of variable 1 or instant value. Now, I'm going to show you how to build a compiler and runtime environment of our project. To build a compiler, just go to the compiler folder and type make. It will generate a compiler for you. And the same thing to build the runtime. Switch to the runtime folder and type make. It will generate runtime for you. Let's go back to the compiler folder. We created a demo program called demo.10. It does the very simple things, declare a variable I and make I is I plus 2 multiplied 3, then print out the value. Let's try to compile this program using our compiler. And it will generate the ASM code, bytecode, and here. Then we try to run it using our runtime environment to get a result of 7. And we also provided 8 test cases by each team member, which will be introduced later. We developed our project based on the development plan. We divided 2 weeks into 4 phases to do an agile development by using test-driven and perform unit test and code review between each phases. Like in phase 1, we will lay out the interface between each component, and in phase 2, we will implement the basic data structures and a simple statement. And in phase 3, we will implement lexical analysis and complex statements. Then in phase 4, we will integrate all parts together to test them and fixing a bug. So every team member has contributed to different components. Like for Katie, she will contribute to lexical analysis and symbol table. For Ximing, he will writing syntax analysis, and for Rendong, he will write semantic analysis. Then for Xiangyu, he will implement runtime environment, linked list, and parsing tree basic data structures. Now, I will give my time to my teammates to demonstrate their works.
Hi, my name is Katie and I did the lexical analyzer, and now I'm going to demonstrate it for you. Now I'm going to do the unit test for the lexical analysis. For the lexical analysis, we made a demo file with a very simple code, and what should happen when the lexical analysis is run is every part of the demo is tokenized. So as you can see, it has been split up into individual tokens. I'm going to use the compiler to run my 2 test programs. In my first one, I have an if-then-else statement, and I want to see if that works, an assignment, and print and for loop. And there's also an if statement that's nested in the for loop. So it counts the number of even numbers between 1 and 25 and the number of odd numbers between 1 and 25. So now I'm going to compile it and make sure that there's something to run, so it's right there. And then we can use the runtime environment to run it. And the expected output was 12 and 13, so it looks like it worked. Now we're going to use the compiler to run the second test case. In this one, I have a nested for if for, so for statement, then if, and then for. Assignments again, and print statements again. So this one takes in a number between 1 and 100. If the number is not divisible by 10, it prints zeros. And if it is divisible by 10, then it prints a certain number of ones equal to how many tens are in that number. So if it's 50, then it's going to print out 5 ones. So we're going to compile this one and make sure that there's something to run, and then run it in the runtime just like the other one. And as you can tell, there's 10 ones at the end right there, so it looks like it worked. Lexical analysis. The symbol table initializer puts in all of the keywords, delimiters, parentheses, curly brackets, etc. into the symbol table to begin with. And there's also methods to add to the table and free the table if needed. After it's initialized, we only add to the symbol table from the lexical analysis. In the lexical analysis, we take in the code that the user has provided and check each element to see if it's already in the symbol table. If it is, we don't add it in, but if it isn't, we determine what it is, either a number or an identifier, and we insert it into the table. A linked list structure is also generated in lexical analysis. This contains every single element from the user's code. The concept of a finite state machine came into play because depending on what character it takes in at a time, it will detect if it needs to keep taking in more into the buffer or if it needs to move on to a new token. And from this project, I had some trouble with the finite state machine at first. It took a while to figure out what kind of things needed to take in one at a time, but after a while, through collaboration, we got it all figured out.
Hi, this is Ximin. My part is parser. Now I'm gonna demonstrate my part, which is parser.c. We can see after we make the test file, we can see the result of the test. For each test case, the first part is the mock token list, which is linked list, and it should be generated by lexical analysis. And second part is the in-order traversal of the parsing tree I generated. Each of us team member wrote 2 test cases at the beginning of this project. Let's check my test case. My first test case is to calculate the number of numbers that is multiply of 5 from 1 to 100. The expected output is 19. This test case covers declare statement, for loop and nested if statement, and print statement. Let's compile the code. As we can see, it generates an intermediate code, and because the expected output is 19, let's run this code. Yeah, it's correct. This test case is to calculate the sum of the even numbers that can be divided by 3 from 1 to 100. The expected output is 816. It covers for loop, nested if statement, assignment statement, and declare statement. As we compile the code, we can see the intermediate code, and let's run it. Yeah, that's the output we expect. Let's get more detail about my implementation. I wrote different functions to generate components in the parser tree. Let's say generate print statement. It will take the token list and symbol table as parameter, and it will check the first element of token list. If it is print, it will keep processing. If it is not, it will raise syntax error, and it will quit parser, and after the whole process, it will generate the parser tree. It is left child and right sibling tree. Also, I want to talk about my challenge. I was not familiar with how to implement object-oriented programming in C, which is not designed to be object-oriented. I spent a lot of time to understand how it is implemented with the help of pointer to function, and also I haven't used text-driven development before. It's hard to start, but when I got used to it, I was also amazed by how we build the program so fast, how we cooperate so well. I appreciate each team member's hard working and help from them. Thank you.
My name is Rendong Zhu. I'm in charge of the bytecode part. Now I'm going to demonstrate my work. Now I'm going to demonstrate the unit test case of the bytecode C to generate the intermediate code. In the unit test case, I got the input fully parsing tree, and the output should be the bytecode generate according to the parsing tree, and to show my test case is correct. The purpose of my first test case is to test if statement nested in a for loop, and also the Boolean expression to see the not equal is working or not. Now I'm going to use compiler to compile my bytecode, to get my bytecode, and the bytecode is success, and to use the bytecode in the runtime to see the output. The expect of output is 27, and yeah, which means it's success. The purpose of my second test case is to test the nested for loops and to see how many times the nested for loop executes. Now I'm going to use compiler to get the bytecode of this program, and then put this bytecode into the runtime to see the output. The expected output should be 5, 4, 3, 2, and 1. And let's see. Yeah, that's it. This is the work I've done to generate bytecode from parsing tree. Here are all interfaces I implemented to handle parsing tree node. The hardest part is to totally understand parsing tree structure and to figure out when and where to append bytecode. For example, in if statement, if there is no else statement in the end of the if statement, it will jump to if and label. However, if there is a else statement, it will gonna jump to else label. Okay, same thing in the for label. In the for statement, in the for loop, the keyword, step, and its expression comes before statement list. But in the bytecode, it have to be appended after the statement list execution. So in this one, through this I understand what is OOP, what is test development driven, and most importantly, I understand how compiler working.
My name is Xiangyu. I'm working on the runtime environment. Now I'm going to demonstrate my work. I want to show you how to build the unit test and print out the debugging message of your runtime environment. Build the debugging version of the test runtime and run the code of the demo code. It will print out all the instructions loaded in runtime environment virtual machine and the execution sequence of the code. Two test cases for this project. The first test case is to calculating the Fibonacci series of the first 6 elements and print them out. These test cases will cover the simple for loop and the declared variables inside the for loop. Let's try to compile it using our compiler to generate the bytecode. As you can see, it successfully generated bytecode right here. Then we can run it using our runtime environment to get the result of the Fibonacci series. The second test cases I wrote is to calculate the sum of all the prime numbers within 100s. This will test the for loop within the nested in the for loop and if statement in the for statement, as well as the if statement parallel with the for statement. Let's try to compile this program. You can see the program successfully compiled to the ASM file, and we can try to run it in the runtime environment, and we'll get a result of 1060. These are my runtime environments files. It composed with different 3 separated files, runtime.c, instruction.c, and storage.c. In instruction.c, I will do the load the bytecode into the runtime environment and replace the label in the bytecode into the real address. As well as I will do the fetch the instruction based on the program counter and change the program counter to a new address. And in the storage.c, I will store and fetch the variables user give to the runtime environment, user defined variables, and handle the variable scope using open and closed scope. Then in runtime.c, I will evaluate the bytecode or the instruction using the evaluate function. So each evaluate function is mapping to the corresponding bytecode in here, global operations. Like for move, I will be using eval move to evaluate.